everyone, and welcome to another deep dive with us. We're diving into the world of programming languages this time. You guys have sent us a ton of articles about this, and we're really excited to dig in. It seems like you're all super curious about what these languages have in common, even when they look totally different, like on the surface.
Yeah, it's like we're trying to figure out what makes them pick. Like, what's their secret sauce?
Exactly. And to help us crack the code, so to speak, we've got our expert here. You always blow my mind with how you can connect totally random things.
Well, I try. I'm happy to be here.
So one of the articles, I think it was the one from scitechgen.com, said this: every single programming language has one goal, giving instructions to the computer hardware. Which, okay, yeah, that makes sense. But then why not just, tell computers what to do in plain English? Why has it got to be all complicated?
Well, that's where we run into a little problem. Computers, they don't really think the way we do. Like, they don't get human language. They're all about that binary code, ones and zeros,
It's like they've got their own secret language or something.
Yeah, exactly. Programming languages are basically like translators. They take what we're saying and turn it into something the computer can actually use, that binary code. Like, imagine trying to have a conversation with someone who speaks a completely different language. You need a translator to make it work.
So I'm hearing you say these core elements are kind of like dialects or something. Like I can say hello in, I don't know, English, Spanish, French. The basic idea is the same, right? Even though the words are totally different.
Yeah, that's a great way to put it. And just like we use different languages for different things, like think about how you talk in a business meeting versus how you chat with your friends, right? Programming languages, they're kind of the same. Different tools for different jobs.
So it's definitely not a one-size-fits-all situation.
Nope, not at all. The SciTechGen article actually, they mentioned COBOL and Fortran. COBOL was used a lot in business because it was, readable. Then Fortran, that was big in science because it was awesome with numbers. Each language has its own kind of, specialty.
Okay, that makes sense. But even with all these different languages, I keep seeing these common building blocks everywhere I look. It's like they all share the same DNA, but they express it in totally different ways.
Exactly. It's like, imagine you're building with Legos, right? You've got your bricks, your plates, those little connector thingies. Those are your core elements. Now, you could use those same pieces to build, like a spaceship or a castle or even like a robot. They just go together differently. Programming languages, they kind of work the same way.
So no matter what you're building, whether it's some fancy app or a website or whatever, it all comes down to those fundamental pieces. SciTechGen talked about variables, data types, and data structures. Those are the big ones, right?
Totally. Those are the essential ingredients. They give structure and meaning to all those instructions you're giving the computer.
Okay, so let's break those down a bit. What are those building blocks really, and how do they actually work?
Okay, so let's take data structures, for instance. The SciTechGen article, it talked about arrays and linked lists, right? Those are two different ways of organizing data in the computer's memory, I mean.
So different ways of storing information?
Yeah, exactly. Picture an array like a shelf, like a really neatly organized shelf where every item has its own spot, And then a linked list, it's more like a treasure hunt. Each item gives you a clue to find the next one.
So with an array, you always know exactly where everything is, but a linked list, it's more flexible.
You got it.
Yeah.
They both store collections of data, but how they do it is totally different. And they each have their own pros and cons. It all depends on what you're trying to do.
It's choosing between a filing cabinet and then just a bunch of sticky notes. They can both work, but it just depends how your brain works,
Perfect analogy. And here's where things get even cooler, right? So we've been talking about these common building blocks, yeah. But what about how they express those blocks? Like how they actually write out the instructions? Because that's where things get really different.
You're talking about the syntax, right? The grammar and the structure of the language.
Exactly. Remember our language analogy from before? English, Spanish, Japanese. They don't all get the same point across, right? But their grammar, their sentences, even their alphabets, they're all different.
So it's less about being fluent in every single language and more about just understanding those basic grammar rules, the stuff that makes them work.
Exactly. And just like some languages have super strict grammar rules, programming languages are the same way.
Yeah.
And that kind of leads into the whole statically typed versus dynamically typed thing. The articles talked about C++ and Python for that.
Okay, yeah. So what's the difference?
So with a statically typed language like C++A, you got to tell the computer what kind of data a variable is going to hold before you even start. Is it a number? Is it text? You got to be specific. It's like saying, this container, only cookies go in here, No milk allowed.
So it's like really strict and organized.
Right. And that actually helps avoid errors because the computer knows exactly what to expect. But then on the flip side, you've got dynamically typed languages like Python. It's way more relaxed. You don't have to declare everything up front. Python's like, we'll figure it out as we go.
So it's more flexible, but maybe a little more chaotic.
Yeah, you could say that. It's like that friend who's got their whole life planned out versus the friend who just like goes with the flow. They both have their good points. It all depends on like the project and what the programmer prefers.
This is blowing my mind. It's like we're peeking behind the curtain and seeing how this stuff actually gets made. But okay, I gotta ask, why should I care about any of this? Like, I'm not a programmer. This is blowing my mind. It's like we're peeking behind the curtain and seeing how this stuff actually gets made. But okay, I gotta ask, why should I care about any of this? Like, I'm not a programmer.
You know, that's a really good question. And it's something all these articles kind of touch on. It's not really about like becoming a coding master or anything. Even if you never write a single line of code in your life, understanding this stuff, like these basic concepts, it's actually really useful.
Okay, now I'm really intrigued. Tell me more.
Well, for one thing, it can make learning new technology way easier. Because the tech world, it changes so fast, right? But these fundamental concepts, they're kind of like, they're like the foundation.
Yeah.
So once you've got that down, picking up new languages or tools, it's not as scary.
So it's like I've got this master key that can unlock all these different doors.
Exactly. And there are all these new low-code platforms popping up. They let you build software without like tons of coding. But even then, if you get the fundamentals, you'll have this like secret weapon, you know?
Right, like you'll be able to actually use those tools well or like figure out what's wrong when things go sideways, which, let's be real, happens all the time with tech.
Exactly. But it goes even deeper than that. Learning about programming, it can actually change the way you think, which is kind of wild when you think about it. It helps you break down huge, complicated problems into these little, manageable steps. You start seeing patterns everywhere and approaching problems with logic. And that's useful no matter what you do.
Whoa, so it's like programming rewires your brain to be like a problem-solving ninja.
I like that. It totally does. It trains you to think analytically and methodically about, well, everything.
Wow, this deep dive has been amazing. We've gone from trying to decode this like cryptic language to a whole new way of thinking about how to solve problems, and it's all thanks to the magic of programming.
It's been so fun exploring these ideas with you.
This has been awesome. And for all of you listening, before we go, here's something to think about. If you could make your own programming language, what would make it special? What would it be able to do? Let us know. Until next time.